Hello there. Welcome back in our series, our lessons in Algebra 1. Today we'll discuss together how we can solve any absolute value inequalities. After we have learned how we can solve the linear inequality and the compound linear inequality, today we'll discuss how we can solve a linear inequality contains absolute value here. So we have two theorems here. I already write it here on the board. So the first theorem says if we have a linear function here, f of x is denoted for a function. If we have a linear function inside of absolute value less than of a, and the condition a that a is greater than zero is positive number, then we can rewrite this absolute value inequality as a compound inequality where f of x is restricted between a and negative a. So how does that work? So if I want to give you an example here, let me change this color with another color here. Good. So let me give you an example here, directly example. Solve the inequality which says absolute value of 3x negative 2 is less than make it 5, for example, or 6. What's important? What's the number here? So I can apply directly because already is written in this form. If the inequality not written in this form, I need to rewrite it as this form where the absolute value alone and a number on the right hand side. I will give you another example later, inshallah. But now I will start by a simple one. So directly apply the theorem here. That means this linear expression, this linear function, 3x negative 2, it will be between 5 and negative 5. Then the next step to solve it, we need to add for all sides, as we learned in the compound inequality lesson, you can revise the video, plus 2 for all sides of the inequality. That is the inverse of negative 2. So we'll get 3x between 7 and negative 3. It will be 3x here between 7 and negative 3. Good. So the next step, I need to multiply all the equation by the reciprocal of the coefficient of x here, which is 3. I will multiply by 1 over 3 all of the inequality here, or the compound inequality, or divide all sides over 3, as you like. That's important. So it will be negative 1 here, and here it will be x, and 7 over 3 as a fraction. So the final set, the solution set, it will be x, where x is restricted between 7 over 3 and negative 2. As interval notion, I can, let me read this one. As interval notion, I can rewrite it as open brackets here from negative 1 up to 7 over 3. And if I want to graph it, it will be between negative 1, I will assume it is here, and 7 over 3, if I assume it's here. So it will be a segment between these 2 points. It's easy. Just apply the theorem and apply what you learned in the compound lesson. That's how we can solve the compound inequality. Good. That's an example on the first theorem. This is the second theorem here. Second theorem says if we have an inequality here, this inequality contains absolute value of which is this absolute value, and this of which it will be a linear function or any function, not important, but I will focus on the linear function as your level. So if a is greater than 0, that's our condition here, I can rewrite this inequality as a compound inequality. F(x) is greater than a, and of x is less than negative of a. Okay? So let me read this example and give you another one. Good. So here, if I ask you to solve the inequality says 4x negative half greater than 2, for example. If I want to solve it, directly I will apply the theorem here because I have an absolute value greater than some number, and this number is positive. I can apply the theorem directly. So it will be this expression, the linear expression 4x negative minus 1 over 2 minus half is greater than 2, or as a compounding quantity, or 4x minus 2 is less than, 4x minus half is less than negative 2. I reverse this inequality here and change the sign of 2 as the application of our theorem here. I reverse the inequality and change the sign of this number 8. Now, as we learned in compounding inequality, we can solve each inequality alone. So let me solve this one. So it will be 4x. Move half to other side. It will be 2 and half. It will be 5 over 2, which means 2 and half. It will be 5 over 2. Now, multiply all of the sides by 1 over 4, or divide all sides over 4. If I multiply all of sides of the equation by 1 over 4 here, I will get x is greater than 5 over 8. As in interval notion, it will be from 5 over 8 up to infinity, open and open. For this one, in same procedure, it will be 4x less than. Now we have negative 2 plus half, it will be negative 1 half, which equals negative 3 over 2. Negative 2 plus half, it will be minus 1 and half, which equals negative 3 over 2. Now multiply all of the sides of the inequality by 1 over 4, same procedure. So I will get x less than negative 3 over 8. As interval notion, it will be from negative infinity up to 3, negative 3 over 8, open bracket. And now I can replace this or by the union side. As we know in logic, or it means union, and we have finished. So this is the interval notion. If I want to graph it, 5 over 8 is a positive number, assume it is here, 5 over 8, and negative 3 over 8, it will be here as a negative number. We have an arrow directed to left here, and an arrow directed to right here. This and this together will be our solution. Good. Now, if I give you a complex expression, how I can simplify it to solve the equation, solve the inequality. Let me give you an example now. I will keep this formula here on the left-hand side, and I will stay solving here on the right-hand side, just to keep revise what we say here. So if I ask you to solve the inequality 3x plus 2 with 6x minus 2 less than 4. Good. How I can solve this one? What's the basic steps I need to follow here? As I said, to apply this theorem, you need to keep the absolute value alone here in the left-hand side, and not important what we have here on the right-hand side. I will assume it as a positive, if not constant here, as our case is as a number variable here. So if I want to start solving here, it will be 3x. I need to move 3x here firstly to the other side. So it becomes 2 multiplied by 6x minus 2 less than 4 minus 3x. That's good up to now. Just I moved 3, it becomes negative 3. Next step, I need the absolute value alone. So we have 2 here. You have 2 choices. You can multiply 2 by all the brackets here, dealing with it as a bracket, but that's not useful if this number is negative. You need to change the sign because we have absolute value. So to do it correctly, just divide all sides over 2 or multiply by 1 over 2, which is the reciprocal here. So I will get, in this case, the absolute value alone now less than 4 minus 3x over 2. Good. Now, how I can solve this one is apply on the formula directly. So this becomes 6x minus 2 restricted between this number. That's important what is. I will keep it. And here I will put the minus of this bracket, the negative of this bracket over 2 as a negative here. The negative sign for all the brackets. So I need to multiply negative 4 plus 3 it will be. Now, I need to solve this one. How I can solve it? It's a compound inequality. It's a hard one, but it's easy if you did it correctly. So I need to multiply all sides firstly by the least common divisor here, which is 2. Multiply all the terms by 2. This first step, it will be negative 4 minus 3x. Sorry, I need to change the color. Negative 4 minus 3x less than 6x with 2. It will be 12x minus 4 less than 4 minus 3x. 2 with 2 cancel. 2 with 6 is 12. 2 with 2 is 4. 2 by this fraction, 2 is cancelled. So I keep it like this. Now, insert this minus 1 to all of the sides of this bracket. It will be negative 4 plus 3x. So it will be negative 4 plus 3x less than 12x negative 4. Good. Here 4 minus 3x. Now this linear inequality, a compound linear inequality, if I want to solve it, we have 2 ways. We need to restrict here to the x is in the middle and put the numbers outside of the inequality. But that will be hard to you. So the best way to solve this one, you need to do it as and. You need to really connect it as and, as we discussed in the compound inequality. So take the first inequality, this one, negative 4 plus 3x less than 12x minus 4 alone, and the other inequality, this one minus is less than this one. 12x minus 4 is less than 4 minus 3x. I will continue here. I need to erase this formula and I need to continue here. So what we get up to now, continue, to be continue here, to have a question. So we get minus 4 plus 3x is less than 12x minus 4. This is the first inequality, and the connection between them, and the second one is a 12x minus 4 is less than 4 minus 3x. Now let me solve this one. I need to put variable together, constant together. So I need to move this one to left hand side, this one to right hand side. So it will become 3x minus 12x, which is less than negative 4 plus 4, it will become 0. Whatever this one, x, it will be a 0 because this is not equal to 0. It will be a negative 9x. I will complete it. Now x is greater than 0 here because I need to divide both sides by negative 9. If we multiply by a negative number, as I said, we need to reverse the inequality. So I reverse this one to become x greater than 0. Good. Now this one, the same procedure, it will be 12x plus 3x. I need to move this one here. Negative 4 to the other side, it will be less than 8. So 15x is less than 8. So x is less than 18 over 8 over 15. So if I want to graph it, this is 0. This is 8 over 15 as a positive number. Open circle. Now a greater than here, I need to direct to right hand side, and here to left hand side like this. So the overlapping is x between 0 and 8 over 15. X, the solution is, the final solution is x between 0 and 8 over 15. So this is our solution. Really, you will not face an inequality more harder this one in algebra 1. In algebra 1, the hardest inequality you will face it like this one. So I started from the simplest case up to the hardest case. You will face it. That's good. Now, by this I will finish the lesson. Please, if there is any questions, anything you want, please don't be shy, and please ask me anytime you want. You have my mail, you have my WhatsApp, you have everything. Just contact me. Thank you for your watching. Goodbye.